If you haven't already, open up your Unity project and open up the hub level. So the first thing you want to do, the setup tells you to open up the danger zone, but we're going to go ahead and do all of this inside of our rigid bodies scene that we've already created, that's already been created for you. So you can just go ahead and drag in your rigid bodies scene into your, trying to get a good layout so you guys can see this. There we go. So just drag your rigid body scene into your hierarchy. So now you should have both scenes here. So your question you may have been asking yourself is, how do I actually make objects interact with the grav null? Well, that's the first thing we're going to cover in the first experiment. So you guys have probably had a little bit of understanding. I think you guys go over what a rigid body is in Project and Portfolio 1. So you've gone over that. You know what a rigid body is. You know it's a component on a game object. So now we're going to show you how to set up an object to actually interact with the grav null. So another thing I'm going to do just for testing right now is I'm going to grab the character container, and I'm just going to move him onto this platform, just so when we test it out, we don't have to run from the hub to this little platform. So this little thing that'll be a little time saver. So I'm going to go ahead and create, so definitely make sure you set your rigid body scene as your active one, if you want to keep them both open. So I'm going to go ahead and create just a regular Unity primitive game object, just create a cube. And now what I want to point out, and I covered this a little bit, but now it's definitely more important to understand it and know the difference. I'm also going to create a level blocking mesh, right? So remember from the very first week when we went over switching, the different pivots, right? So if I put this at its pivot, the level blocking meshes pivot from the corner of the object, right? That's super helpful for building your level, rotating them. That's more used for blocking out levels. They've been designed to be made as static objects. Yes, you can make them physics objects, you can animate them, you can do all kinds of things with them. But their intent, the design, was for them to be static objects to block out your levels. So with the Unity primitives, you'll see that the pivot is in the center of the object. So to go ahead and make these, first things first, to make them interact with the grav null, we need to have a rigid body component on them. So just go ahead and search for rigid body. You can add that component. All right, I'm going to go ahead and do it to both of my objects so we can compare them. All right, so now if I go ahead and play, I should be able to walk up to these and kick them around. Now they're colliding with the player. But now if I grab them with the grav null, still nothing, no interaction. So in order to actually make this function, how the grav null works is by checking for an object's tag. So if you take your objects and put them on the fizz layer, that is the tag that the grav null is looking for. So pretty much what you need to understand is if the grav null collides with an object that has the tag fizz, go ahead and do its thing. Pick up the object, pull it towards the center, have it follow along with the player. So now if we go ahead and test this out, I should be able to pick up the objects now. So now also notice, like I mentioned before, when I pick up a level blocking mesh, look what point is at the center of that grav null sphere, right? It's the corner of that object, because that's where the pivot is. So if I pick up the Unity primitive, it feels a lot better, right? It's in the center, it feels like it's where it should be. And then definitely remember you can use Q and E to rotate, as well as Z and X.
Two questions.
Questions?
I guess I loaded up incorrectly or something like that, because as soon as I play it, my character just falls through the level.
You probably moved your character for testing your map or something. Where is your character over geometry?
Yes, it's not like I'm sitting around or anything. It's over. It literally just, I know it's right here though. Like your platform is not.
If you put him over the hub, can you put your character over the hub level?
Yeah, it's fine over the hub level because it's your body level.
Then does your
platform have a collider on it?
Oh,
You can remove that as well and put in your own platform. Other question?
I don't have the fizz tag.
Are you
He doesn't have any of the jacks. He's got all the default ones.
are you in the project that we've set that you've been working on all month, or you created a new project?
No, I'm in the same project.
Alrighty, so we've got our two objects here with both of them have a rigid body. So I'm going to go ahead. I'm not going to use the level blocking mesh. I just wanted to show that. Let me show this because I didn't have my screen recording. So the level blocking mesh, right, pivots from the corner there, and the unity primitive will pivot from the center. So while you're doing some of your rigid body testing and setup, you'll probably want to use the unity primitives, and then eventually those will be replaced with meshes, actual just objects. So I'm just going to pull this off to the side. So for this one, I'm going to call this heavy block. So another thing we're going to cover in the first experiment is physics material. So I'm just going to go ahead and duplicate this a few times. I'm going to call one of these ice block. All right, so heavy ice block and stone block, or rubber. All right, so the rigid body component itself, so mass and drag, these two are really the two meat and potatoes of the rigid body that you want to be messing with to make an object feel a certain weight and have a certain heaviness to it, right? Because when you pick up a metal object, you want it to feel heavy, like there's density to it and it has weight. So the mass, straight off of Unity's website, is the mass of an object. That's how heavy the object is. So the drag is how much air resistance affects the object when moving from forces. So let's just go ahead and play with these and mess around with them to get a sense of, what ranges feel good with the grav null. So let's give this an object a mass of 10. Let's give this one, so with the drag as well, this will always range from usually 0 to 10 is a good range. So the heavier an object is, like a metal block or like cement or wood, things like that, will have a lower drag. So you'll be able to pick it up and it'll immediately clunk and hit the ground. Right. So for my heavy one, let's go ahead and give this a weight of drag of 0.01. And now for the time being, this rubber block, I'm just going to experiment, and I'm going to give this a drag value of 10. And for the ice right now, let's just go middle of the road. Let's give this a mass of 5 and a drag of 2. So really just play with these and test them out and come up with a bunch of different settings and see how this could apply to a level. So here's the one that has a mass of, a drag value of 10. So now you see when I let it go, it slowly floats to the ground. So how could you apply that to something in a level?
That's the drag that's high?
The drag value, yes.
And what was the mass on that one?
I think this one just has a mass of, I think it's still a value of 1. I haven't messed with that yet. So this could be used for like a balloon or something that's very light, right? Very, very aerodynamic, a feather or a leaf, right? If you have something you want to pick up and slowly fall to the ground, that's a use of that. So here's the metal block here. So now you'll see when I pick this up and I let go, it immediately falls to the ground. It's very quick, very responsive. That's the 0.01 setting. And this one's also a little bit heavier, so it's a little bit tougher to carry around. But definitely you can tell that it has some weight to it. Now here's the one that's in between. This is a mass of 5. This has a drag of 2. So it falls a little slowly. Could be adjusted even further, but it has a in-between weight to it. All right, so the next thing to keep in mind as well, so I'm just going to take my heavy block here and duplicate it. I'm going to take this one and scale it up by, let's give this a value of 3. So this one's 3 times the size, right? But they have the same mass. So that means they should behave the same, right? Because they have the same mass. Let's try it out. Pick this one up, feels pretty heavy. Try and pick up this one, and like lift it over my head and throw it. So this goes to show you that the volume of an object, the size of the object, is definitely in proportion to the mass itself. So just because an object, right, because if these are made of the same material, and I go to pick up this one, I can pick this one up over my head and throw it. This one should be much more difficult, right, because this is much bigger, should not be able to pick this up as easily. So if you make objects larger and you want them to feel heavier, made of the same material, you need to adjust the mass accordingly. It's almost like have you ever seen the triangle from physics, the dmv, the density equals mass over volume, and then you do like mass is density times volume. That's very much applies to this as well, right? If your object is larger, you need to make the mass larger if you want there to be a higher density, if you want the object to feel heavier. Any questions at all about mass and drag?
Is there any point in time that it would be reasonable to actually take the mass over 10?
Oh, totally. Yeah. I mean, if you want, like, that's just something to.
I was looking at the Google Doc yesterday.
Yeah.
It said usually you only need to go from 1 to 10.
That's for the drag. Is that what you said? Yeah, for the drag, though, you're really not going to get, like, you can test it out yourself, too. Like, set something to 100 drag and set something next to it that's 10 and just compare the two. They're about equivalent. It pretty much gets capped out at 10. And you'll notice in the Unity documentation, for this assignment, I link a lot of directly right from their docs for these. So you get a really good understanding of this is coming right from what Unity has designed. Here they say a solid block of metal would be 0.001 for your drag, and a feather is a value of 10. So you can tell that those are completely separate objects, and that range is pretty small. But for the mass, you can definitely make something larger than just 10. Like this is a mass of 30. I'm still able to pick it up and move it around, but it feels very heavy. Rodney, do you also have a question?
Yes. So, is it the mass that, like when the cube is falling, is it the mass that changes the speed of the fall? That's the drag. Oh, the drag.
The drag, yeah. Drag changes the free fall speed, basically the air resistance. So, all right, so that covers mass and drag in the rigid body. So by default, you'll see this is gravity checked on. So you'll see that if you turn this off, you'll notice that your rigid body doesn't affect gravity until the player interacts with it. So that's also a script you'll see in your project. Pretty sure it's called Sleep on Awake. Yeah, so this rigid body sleep. So if I put this on my object, and it's just a little extra stuff that you'll get into this more, but this is pretty much doing just that. It's going to keep this object asleep until the player interacts with it. So you can go through your level and you're building it and put those. In case you'll notice, like in the danger zone, there's this Jenga tower. Without that, you'll see as soon as the level started, just like explodes. It just goes everywhere because a bunch of colliders colliding with each other. So that'll be useful in certain scenarios. But that's what that script is doing, is basically this functionality here in this use gravity. It's just made easy for you in a nice packaged up script. So this is kinematic checkbox. This one's also really useful. So this is used for a number of different things, and I have a link in the assignment. It's in the experiment itself that will talk to you just about this is kinematic function and what it's doing. But really, one thing that you guys can definitely make useful is it'll allow you to animate an object. So an object that has a rigid body on it, you'll also be able to animate it, have different states on it. So maybe you have like a platform moving back and forth, but when the player jumps on it, you want there to be like a little tension, a little spring back. So things you can do like that. Also, it's very popular. You guys probably won't ever use it for this, but for ragdoll, it's used for characters that will enter that ragdoll state. That is kinematic, gives them that ability. Yeah, so basically it's just set my joints to move freely and then collide with anything in the path. So basically, a lot of games will go to that where if a player dies, rather than have a death animation, you'll just send the player into ragdoll to make it feel more dynamic, like you don't see the same death every time. So the collision detection, by default, it's going to come in as discrete, and you really aren't going to ever want to change it from this. Pretty much leave it as discrete, and you'll be fine. Take a look at the other ones, though. In the experiment, I'll talk about pretty much these two right here, the continuous and continuous dynamic. Really, you can use continuous dynamic if you have a setup in your level where you have rigid bodies moving very fast. You're either throwing them with the gravinol or you're trying to animate them to do something at a very, very extreme rate. Sometimes the collision will just break, and that's because with the discrete, if here's your wall, you have a wall in the middle and an object on one side, and one frame it's here, and the next frame it's here. Unity doesn't know how it gets between there, so it's just going to pop in between. But with continuous dynamic, it's going to basically check and see how it gets from here to here, and if there's something in the way, prevent it from happening. So use this sparingly. You don't want to just throw this all over your, put this on every object and, think nothing's going to be a consequence to that. So really only use this in a case-by-case basis. Just know that by default, discrete is what it comes in with, and that should be good enough for what you guys are building. And then constraints, we're going to get a little bit more into that for experiment number 3. But constraints are basically exactly what they say they are. You can lock an object to only move in a certain direction or position, right? So if I want this object to only move in the y-axis, I can freeze the x and the z, and now I can go up to it, and I can only slide it up and down. I can't move it left and right. So really, really good stuff for creating setups, creating little interactions and puzzles using just this rigid body component that you can definitely apply to your level. So that about covers it for the actual rigid body component. So the next thing we're going to do is create or apply physics materials onto our different objects. So physics materials are separate from an actual material that's going to display to the screen or to the renderer, right? So here in your mesh renderer, here is your material for, what the object's going to look like. What's, what material, what texture is on this object. But in the box collider itself, you'll see that there's another spot for a material, right? And in parentheses there, it's looking for a physics material. So basically, this is going to allow these objects to behave differently when they collide or interact with other objects, with other things that have physics materials on them. So for our heavy block, I'm just going to go ahead and add, so I hit that little circle next to the material. This window will pop up, and you'll see in the project, you've been provided a few starter physics materials. So let's go ahead for the heavy block. Let's put the stone material on it. On the ice block, I'm going to go ahead and put the ice material on it. And then for the rubber block, I'm going to go ahead and put the rubber material. So now if I go ahead and actually look at one of these materials, let's take a look at the ice. So there's a few attributes in here that make up how this object actually works, right? So the bounciness is basically how much force will be applied to the object when it interacts, right? How bouncy it will be. And then the friction is how much friction is going to be applied to this object when it collides. So you can just look at some of these to get an understanding of how they're set up. Don't change them just yet. Leave them as is. If you want to change them or mess around, I recommend making a duplicate, like just copy the ice and then rename it to something else and then mess around with it. That way you have one that is that default state. But this is pretty much what's going to be modified and adjusted to create these different effects. So if we take a look at the rubber, right, so very high bounciness. And all these values, keep this in mind as well, all these values, the dynamic friction, static friction, and bounciness are all a range from 0 to 1. So if you see 0, that's real low. If you see something close to 1, that's real high. So here you'll see bounciness, 0.9, that's pretty high. So definitely gonna going to bounce a lot.
What's the difference between dynamic and static?
So dynamic is colliding with other dynamic objects, other rigid bodies, characters, things that are dynamic in the level. So static friction is colliding with objects that are static within the level, that aren't moving. And that brings me to a good point that I don't know if I'm pretty sure I didn't cover this at any point, and you may have heard this already, but a good thing to point out. So static, you may have heard like, well, what is a static object? And that's something that isn't moving in the level, just a basic object. And most likely you can like have your lights baked to it. You're using level blocking meshes, just your geometry in the level. So you'll notice this little checkbox up here as well. This will become way more important in like Project and Portfolio 3 when you build a massive level. But all of your objects in the world that aren't moving, that are just staying there, right? So this platform, these little archways, all of this stuff, if we were to make a build of this, we would check this as static. So that what that does, that'll help out when you actually go to build your lighting. So it'll take all of the static objects and bake the lighting to those, and then it'll calculate the dynamic objects in game. So that'll help out when you actually go to build the project. Not really useful now, but that kind of ties into what you're asking, difference between dynamic and static. That's what it is, and there's another way to that unity. You'll see that word again, that word static. Yeah, but then for the material itself, that's useful for when I collide with when I collide with dynamic objects, what's my friction like? When I collide with static objects, what's my friction? So another thing we're going to do too, if you want to create a nice little ice rink or something in there, you can go ahead and do that if you'd like to. I'm just going to take this little platform here at the bottom, and I'm going to apply the ice to it as well, because for the ice to actually behave how it should, you need to have ice collide with ice, right? So hopefully it's not too hard for the player to walk around. No, all right. So now I just pick up your different objects and mess around with them. So notice I take my ice block, and now it'll slide pretty well on the on the ground. Also here, if I mess with my my mass of it, let me put this down to like 3. Change my. All right. So now when I pick this up and slide it, it slides a lot further, right? Still same physics object on it, or same physics material, but the distance it's going and the force that's applied to it is directly in proportion to the mass of the object. Whoop.
Would the player need to have like an ice material in order to be able to slide on?
I think you can. I think that the player the player would need a physics material on him. I think right now there is no physics material on the player, but that would be a way to do it. Maybe you could create another type of material that has a little bit of friction, because you don't want to be like, if you put like ice on the player, it would pretty much be walking around like I have ice on the bottom of my shoes. So even if I walk on stone or wood, there's still going to be a little bit of friction. But there's a way that you could have like a trigger volume, right? Like you have a trigger volume around your area that when the player enters, change the physics material from this to this, right? Or change it from here to here. But yeah, that would be a way to do it, is to have that on the player so he slides a little bit. All right, and then here's my rubber block. So I picked this one up. Oh, and this one still has the, got to change that. So for my rubber block, I'm pretty sure I have actual settings in here rather than just messing around. But part of this too, when I went through and made these experiments, you'll see, put the value to 4 and set the drag to 0.5. Those aren't like set in stone. All right, my rubber block has to have these values. It's just numbers that I felt, had a good feel to this. And this is where the design comes in. When I say, okay, you understand mass and drag, now make me a metal object, a wooden plank, and, a bag of feathers. Being able to actually design that and balance out those numbers are where the design comes in, and the systems will become effective in the actual level. So let me change this back to 0.5. All right, so yep, you'll see the rubber block already is bouncing around. Has a lot different behavior than, say, the same thing with the ice. I go and set the ice down, it doesn't bounce at all, it'll just slide. And now the stone really doesn't have much of a behavior at all. It's just a big grump. It's just, I throw it and immediately just sticks to the ground.
So the stone component is higher on mass and drag?
Anyone know the answer to that before I select it? You're correct, it has, the drag is low, right? Low drag means,
Sorry, it falls faster if it's has lower drag.
yeah, it'll fall faster with low drag and it'll fall slower with higher drag.
Basically, you want to kind of inverse your values for the mass and the drag.
Yeah, that's a good way to think about it. Yeah, you want a high mass and a low drag. That's a good way to think about it, definitely. And definitely don't just, you'll learn this a lot too coming up in the systems class where don't just say like, okay, here's my mass of 30. Well, that's too much. All right, let's try 29. All right, well, that's too much. Let's try 28. Really just think about it in incremental steps, right? So, all right, 30, that's way too much. Let's try 15. Okay, that's too much. Cut that in half. 7.5. All right, that feels a little bit better. How about 12? All right, we're getting closer. 10, really reductive, really reduced down. And you'll definitely get a lot deeper into that when you go forward, but you'll save a lot of time by actually working through that process. So definitely use this as a little testing ground, this experiment area here. Use this as a testing ground to create a few different objects of different sizes, of different material types, and make them feel like they're that material that you're going for, and really try and make it as balanced as possible. All right, so that is about it for the first experiment, where I was just about to save my scene and just go over to Perforce, and I just want to reconcile my scene. But that may be it too. Make sure you checked it into Perforce, or maybe you like got the latest or something and it went back to a
Okay, I know you said this. What was the difference between the regular drag and the angular drag?
The angular drag is, let me pull it up so I know exactly what. I think angular drag is used more with hinge joints and basically things that are rotating on an angle. Yeah, so how much air resistance affects the object when rotating from torque? 0 means no air resistance. Note that you can make the object stop rotating by just setting its angular drag to infinity. You cannot make the object stop rotating. So yeah, it's basically when an object's, that's a good point, because when we get to the hinge joints in experiment 3, you can adjust your angular drag for how much, basically how much WD-40 is on the hinge. All right, so I just, if I'm not mistaken, the only thing I changed so far was just my scene. So I'm just going to reconcile my scenes folder. All right, and it found that rigid bodies was modified, and also found the hub was changed. That's probably from me moving the character. So I'm just going to go ahead and reconcile those. All right, and submit. All right, just submitting that change list. So definitely still use this week to get your practice in with Perforce. Make some changes, get comfortable doing some stuff, even like the issue Nick ran into where his project settings were all screwed up. Maybe make a change to your project settings, adjust something in the project settings, come in here and get practice actually reconciling something other than the assets. Step out of your comfort zone a little bit this week and really get versatile with communicating between Perforce and Unity.
Is it a bad thing to reconcile only the assets to get it from the
No, that's fine. When you're doing that, you're not gonna. If you change something in the project settings, that won't get changed. So you have to always do it from one of these folders, but never the root folder. All right, so. All right, so any questions at all about the first one? Pretty self-explanatory, right? Everyone, if you're for whatever reason like, man, I just can't get my physics object to work with the gravnol, probably didn't set the tag to phys. The amount of times I've forgotten to do that are very large. So always just double check. Needs a rigid body, needs a phys tag for it to actually interact with the gravnol.
How come when you're moving stuff around with the gravnol, it changes the color of the block?
That's a good question. So why does the gravnol change the color of a block? So that is a debugging thing that we had put in there for basically just feedback to the user that it's being picked up. So here you'll see this, the debug. If you go all the way into camera, pivot, camera, gravity gun, here's where the actual gravity gun script is. And you can adjust some of this stuff now. I'll tell you that it's okay to play with this stuff while you're here, but don't go forward with this in building your level. Wait to make these final changes to when you get to your team setting. So like in here, the push force magnitude, basically how far you can throw an object. What's the force when I right click with the gravnol? What's the force that's being thrown to it? So the instructor that wrote this really took the time to like put in all these tooltips, so you really can understand which each one of these are doing. He's an incredible guy. Put in a lot of work into this. You can do that. We tried that for a while, but it was like it always made these stacking puzzles where you would basically have to put 3 blocks in the right place. You set one down, you go over to pick up the other one, and you set it on top, and all of a sudden you're like picking up both. And it just became really cumbersome and frustrating. Like it was cool, you like pick up a bunch of like trash on the ground and just like throw it. But it kind of changes the design of your level. So that is something that's there. And we've been shying away from that and just sticking to just one object at a time because it'll make the interactions better. But maybe there's a zone when you get to a part in your level where you trigger that on, right? You get to this area now, like, you have an upgrade. Now the player can pick up multiple items at once. So it's there. It's available to you.
Well, what made me say something about it is because it kind of, who is it? Cone, right? Doing the singularity thing?
Yeah.
So that could actually work well with his mechanic.
Yeah, well, that would basically be like a copy of the gravity. You would copy the gravity gun and modify it to be a different version. But yeah, that would be one way. You'd want to look at how they're picking up multiple items there. But you're asking about the color. That's on this right here. So it's just meant to be a debugging thing. Eventually, you can turn that off or have a nice, when you get to Project Portfolio 3, have a nice like material change or a particle effect, some little gamey element when you're actually picking up an object. But right now, that's just communicating to you that it's working. That's what that color change is for. All right, so for question?
You said he wrote the whole script for the gravity gun. How do you put the info text?
The tooltip?
Yes.
I'm gonna let you look that up. Maybe we can take a look at that in lab, but we'll get through some of these experiments, and then we'll have the rest of the day today to answer any questions like that. I don't know myself. I think it may be like a serialized field, but
it's a tool. It's in brackets. It's tooltip, and then parentheses.
And then what it is?
With a string inside above the variable that you want.
Okay. Nice. Alrighty, so for the second experiment, we're going to be this one, we learned about complex game objects already from the wind turbine, right? How to set up a complex game object with multiple objects in it. Now we're going to talk about complex colliders and adding a complex collider to a complex game object. So this is something that definitely comes with practice. It may be easy for some people to pick up. It may take a little bit of practice for these objects like this that aren't just that aren't just have a box collider on it, aren't just like a very simple shape to put collider on. You have to put a little bit more effort into making this collision feel accurate, because especially in the game Scraps, when we have this third-person character, and even it's like almost like pseudo first-person when they're over the shoulder, you can get really close up. So the collision is definitely in first-person games as well. The collision is important. You can't just skimp on that stuff. So what we're going to do is put collision on this pallet jack object. So you should already have the entirety of the IND or the Scraps Assets folder. So if you just right-click on your Assets folder and import package, I'm going to import a custom package. All right, I'm just going to navigate to my Asset Depot, and let's see. This should be in Business and Pallet Jack. So here it found all the goodies, finds the material, the texture, and the FBX file. And by default, it's probably going to dump all of that stuff into your art assets folder. So what I'm going to do also for this, just like we've been doing, I'm just going to create a new folder. Call this rigid bodies. So where did I find the package? So it's in the Scraps Assets, Scraps Asset Depot, Business, Pallet Jack. So I just created this rigid body folder. So I'm just going to take this Pallet Jack folder here that was imported. I'm just going to drop it in my rigid bodies. And so this isn't necessary. I'm just doing it to stay organized again and make my life a lot easier when I go to actually set this up in Perforce. All right, so if you open up the Pallet Jack folder, you'll see this object. Let's go ahead and drop it in your scene. Everyone got the Pallet Jack? Oh, it's like a collaborative no. All right, so we'll put our object, put that object in there, and now let's just play and see what happens. Well, I can walk right through it, right? There's no collision going on at all. I'm honestly even surprised it didn't fall through the floor. So there we go. So the player can walk right through it. So what we need to do is, oh, and it's in the hub. Make sure that everything's going in the correct scene. Set active, save it. All right, so we got to make sure that the player can collide with this in a believable way, but not so much to where we don't have to put individual pieces of collision on the handles and think. We just need to block it out as best we can. So there's two different ways to go about doing this, and when you use these two different ways, it could be used depending on what the situation is you're actually going to be doing with this object. So one thing you can do is create a component, is create a box collider on our object. Boom, done. Right? Got our collider on there. Looks good to go, right? We're done? No? Exactly, right? We don't want something like this to where the player can that jump I never changed. Right? We don't want this scenario. This isn't believable. This is not what we're going for. So what we can do from here, so with this box collider on the object, you'll notice that there's this edit collider that we talked about a little bit already. When you select that, the little faces are selectable. So you can go ahead and drag these into place. So you just drag these up to best. And I'm going to put the first one around this base of the object here. All right. And then when you're done, you can turn off that edit collider. Now let's see what happens if I add a rigid body to this. Okay, and let's also tag this as fizz. Let's test this out and see what happens. So now I can pick up the object from that base, right? But the other parts of it still don't have collision just yet. So from here, what you can do, and let's just go ahead and duplicate this before we go any further. So we have pallet jack and pallet jack 1. So for this one, that we have our collider on it, what we can do from here is we can start adding more box colliders or other colliders to this object, right? So just start taking multiples. Now here's the part why I don't prefer this method, is because one, Unity doesn't allow you to rename your components. So you're going to have just if you have multiple box colliders on an object, they're just all named box collider. So you're going to just have to discern which is which and be able to, remember or have the patience to select through them. Not without writing a custom script, I'm sure.
In the settings for parsing, I'm pretty sure you can change that in the code settings so actually
Yeah, but wouldn't that would change the class before?
Yeah.
Yeah, you're saying like each individual one?
Yeah.
No. Mm-mm. So go ahead and add a few more. I'm going to have one more for the neck, and then one more for the handle. So this is really nice though if you're just having your collision on an object. If you're not messing with this object at all once it's built, this is probably the preferred way. This isn't the way that Unity writes in their documentation, but it works, and it's all contained to one game object, right? So now if I play, question?
Would it be better if we made one separate for the handle and neck, or is it fine to just stretch it over both?
Yeah, that's fine to put one over the two. I'm gonna show a little bit of a variation to where you can have. Yeah, that's okay for now. That's fine. All right, so now I have this over here, and this looks pretty good. So I could definitely adjust the mass and make it feel a bit heavier. But definitely you'll notice now when I have these multiple box colliders as well, no matter where I select on the object, I'm able to pick it up. Whoop, and it's gone. So on this other one over here, if I instead right-click on the object and create an empty game object inside of it, all right, I'm just going to rename this Collider 01, and add this component, and I'm going to add the box collider to this. So this way, not only can you instead of using that edit collider, you can actually just go ahead and move the game object, which is really nice. So that's a little plus. You can also edit the collider here, but this is acceptable as well. So with this is really useful if, say, you want to animate one of these, or you add parts onto an object, right? Like say the handle of this is missing, right? So the handle and that collision volume is separate. When the player attaches it, you instantiate that one or enable this game object. So this gives you a little bit more flexibility if you want to modify these like during runtime or based on a player interaction. You actually can, find game object named Collider01 and do something to it. So this gives you a little bit more flexibility. Both of these ways are correct. Unity will both accept them, but also keep in mind too how they're going to perform differently with the grav null as well. So this way, what you're noticing is this object. I'm just going to keep the rigid body on this game object. I'm not going to be putting rigid bodies on these other colliders. So this is the part where I may be, if you think I'm doing this really quickly, part of it is I'm definitely doing it with some time constraints for the lecture, but also that I've been working with this stuff for a long time. It may take you a while to get the hang of this and feel comfortable with something and know when to make something the size of the actual object, when to make it a little bit larger. So it's all with practice. So definitely take this stuff seriously and have fun with it. Take some weird random objects that you find online or find on the Asset Depot that aren't just super simple to put out collision on, and try to put a decent collision volume on the object. So now let's pick these up. So now this one you'll see. So this one over here, to the right over here, this is the one that has the multiple components. This has multiple box colliders on one object. This one over here, you'll notice I have a collider there on these feet, and even if I walk over it, I'm standing on top of them, but I can't pick this part up with the grav null. Same thing with the handle. So the only spot I can actually interact with this is on this base. So this could be something you could also think about using in your level. Maybe I change this around to where if I make this collision volume here, the one with the rigid body, now I have to maybe grab it by the handle. So it's a little bit more realistic, right? Or a little bit more fitting to what the object is doing. And now also what you can do with this to take this even further is let's go ahead and, this is a little bit of foreshadowing into the next experiment, but let's go ahead and freeze the position in the X and the Z. No, sorry, in the X and the Y. Only allow it to move in the Z axis. So now this could be like it's on a track, right? Now I can only slide this one direction. This could definitely be used as a setup in your level. Some type of interaction. Up in there you see it's rotating, so if I wanted to stop that, I would have to freeze the rotation. So a lot of good stuff here, and two different ways to accomplish the same task. You can see how these behave about the same, but there's minor little differences, right? These key little differences can definitely affect the gameplay.
So a second ago, you had the pallet that spinning in the box.
Yeah?
How do you prevent the rigid body?
I wish I knew the answer to that, because I can definitely point out a few things that are a little bit wonky with the constraints and with rigid bodies. I mean, sometimes there's just a little bit of, I mean, this is a technical piece of software, and sometimes there's just these little hiccups like that. If once you have a core base of something functioning, then we can work with when you get to level design and moving forward, you can work with cleaning up those visual issues. But for now, just focus on your functionality and getting good design setups, and then worry about that stuff later, because that won't really.
At least to me, it seems like having a shape like that, like with my puzzles, right?
Yeah.
A shape like that could possibly cause a problem with the ability to solve it.
I don't think it's going to be that big of a. I think get it functioning first, and then we can work on, revising it and improving it. But I don't think you'll be running into a big issue with those. And then also, that brings up a good point as well. You may not, now that you guys are finally learning physics and learning the rigid bodies, and I don't show you guys this in the first week because I don't want there to just be a level, it's just nothing but physics objects. So don't get this mentality of, I got this cool new hammer, now everything looks like a nail, right? Like, don't use physics everywhere. Just use them sparingly, use the constraints, because they are wonky. As Cheryl was just saying, there are these little hiccups, there's these little glitches, these little weird conditions that'll happen. It's just physics. It's all being calculated dynamically. So sometimes things aren't going to go exactly how you want. So with the balance of understanding animation, where this is going to happen every single time the same way, and physics, where it's a little bit out of control, but it's a little bit dynamic, and balancing and using the two together, you have a lot of good knowledge to create awesome stuff in your levels. All right. So that about covers it for the second one. Second experiment. So I'm just going to drop my pallet jacks that I created in here with the two separate collision setups into my rigid body experiments folder, just so I have them saved if I want to put them somewhere else in the level. Save my scene. Let's come to perf. Did I? Oh. Well, the objects are down here. Let's see.
Okay, so like, you have two stages in the hierarchy. You save, mark the new things, the one that's active, will it save those new things in the active scene? Or just like your
That's a really good question. The whole multi-scene editing is still pretty new to most people. I still, like, if I'm working on one contained scene, I'm just going to have that open and not have that. I would try it out though with like a very contained scenario where like create an object, save the scene, and then see what it does. I don't.
try it like for next month.
There you go. Without checking into Perforce at all the whole month.
I'm pretty sure it saves all the scenes in there because there was no asterisk in the big body ones, even though my hub was active, the asterisk was on the big body.
Oh, this freaking.
So I'm pretty sure it saves all the scenes, regardless of which ones are open.
It does.
I'm not sure.
No, it does.
It does.
I had to re-import my whole drive in.
Why?
Alrighty, so that's all the good stuff for that experiment. Alright, so for the last experiment, we're going to write a very lengthy script to have all these setups happen when we press play. No, I'm just kidding. No more scripting. You guys had to write your. Rodney got so excited. He's like, yes. He's like, yes. No, this is what's really nice is we're showing you a lot of the stuff to showcase that there is a lot of design and a lot of decisions and creativity you can do, a lot of setups you can do in here that aren't necessarily require scripting. Yes, it's going to make your levels better, but a lot of stuff what we're showing you is built into Unity so you can utilize this going forward. So we're going to talk a little bit about constraints with rigid bodies as well as cover some hinge joints. And I saw that there was a very common theme this month where there's like cables or like ropes of some kind or like not tires. I think like one level had like a chandelier with like a wire coming down and the chandelier is going to swing. So we're going to also, if we have enough time at the end, I'm going to try and show, I have a little example that I was working on, also show you a little bit of a usage of how to like create something like that, how to create a cable or rope within the confines of what Unity has provided for you. So you'll see in the experiment, a lot of the stuff was done in the danger zone, but feel free that we're going to do all of this in our new rigid body little experiment scene there. So these are just little setups that I had created. This doesn't necessarily mean that you have to build it this way. This is just something that I had put together that I thought showcased good minor, excuse me, it showcased a good minor setup as well as showcased using hinge joints and constraints as well. So let's go ahead and get this guy out of here. So set active. So first thing, I'm just going to create this small little base here. So first thing I'm going to do is create a level blocking mesh. Let's see, and this has a scale of 3, 1 in the Y, and 5 in the Z. Drop that on the ground. All right. And it's definitely always a good habit to try and stay as organized as you can and name everything. So let's name that platform base. And the reason I only had them color coded in the assignment, that's not how they should be textured. It's just to showcase the different objects rather than looking at everything with that grid texture. All right, and now we're going to create another object. Let's give this a scale of 1, 0.1, and 5. Oops. Duplicate first, that would help. 1.15. So this is going to be the board that's actually going to slide. Let's call this sliding board. Alright, now also I'm going to create this small little bumper at the back here. You'll see in the little image there's a yellow frame around it. That's just to make it believable so that this object only will move in this little confined area rather than being able to slide it left and right as well as back off of this little platform. So this one has a value of 1.5, 0.2, 0.7. Alright, and just position this. Alright, so now this object here, right, our sliding board, this one is going to be the one that's actually going to move. So let's give this object a rigid body. I think I have a, let's go ahead and put a material on this. I'm going to create a material, I'm going to call it blue. Just give it a color of blue. Just something to make it easy, a little bit easier to look at. I'm more of a visual person rather than looking at just checkerboard. I like to see a little bit of difference. So this sliding board here has a rigid body. We can adjust the mass to make it feel how we like. All right, and then this little back one here, this is called stopper. All right, so this one has a rigid body. So I need to, let's see, what do we want to do with this object? We want to freeze its rotation, we don't want it to rotate, and we only want it to slide in the z-axis. So we're going to freeze the x and the y. Bless you. Now we also need another little platform. We're going to call it tall platform. Alright, this one should have a 2 by 3 by 2. Let's put this one out here. Alright, so this one I just created about 4 units away from this plank. So now if I go ahead and play, you'll notice that this object, this platform here, is tall enough that I can't jump on it, right? So I need to actually interact with it. Oh, but my board, I can't interact with it. What did I do wrong? Yes, exactly. Thank you. That was a test and everybody passed. Set that to fizz. Alright, so now I slide the board, but I still can't make it up there. What would I ever do? So you can go and take one of these handy cubes we created, probably not the rubber one. No, I did not. I froze the rotation as well as I froze the position for the X and the Y. So it's free to move in the Z. See it right here. So you'll see that the reason why I made this 3 tall, right, rather than 2, and this was something I had showed. I showed Dax after I came up with these experiments, and he was like, wow, that's an immediate A plus. And that was pretty much because, there's multiple actions. So here in the assignment, I have you in the rigid bodies. If you were to do this in the actual danger zones, there's collectibles all around. So you can imagine having a collectible right up on here that the player can obtain, right? But in order to get it now, I need to perform 2 actions, right? Slide the board in place, move the cube onto the board, and now jump up. So actually three actions. And this is the type of setup that we want to see and we want to be looking for. So if I just move this over here, let me move one of these guys over and make sure it's not super heavy. Set this to 8. So this is the type of setups when we're talking about 8 to 10 seconds of gameplay. This is the kind of stuff that I personally would like to see. Like, slide the board, move the block, then jump up. And if I didn't screw that up, if I ideally did that, that's about, your 10 to 12 seconds of interaction, right? No scripting. I didn't do any scripting there. That was all just placement of objects, putting a rigid body on a certain object, right? So that stopper is there for being able to make it believable why I can't go back. Also, that's why I had little trim pieces. But that's the type of setup that I'd like to see. Question?
Earlier in the course, you had said there's a way to snap physics objects into the environment. Or is that scripting? What's the object that you would trigger in the set of position?
Oh, to physically snap.
Instead of just having it free spinning when you're moving.
Oh, you're talking. I think you're talking. I think we're talking about 2 different things. So you're talking about when you pick this up, you want to like rotate on intervals.
Yeah, so it wouldn't be as hard to finish a puzzle trying to get the physics object to a certain.
Oh, you're saying, okay, so what you're talking about is having a trigger volume here. So when I get this cube close to the volume, it'll just lock it in place. Yeah. That's something you'll definitely learn in level design, but it's stuff that you have already you already know it. Yeah, right. So we've talked about on trigger enter, right? So it would be an on trigger enter. Basically, if it is object of this name, do this thing. Destroy game object, and then instantiate an object. Or instead of instantiate, what you can also do is basically have another one in your world, right? So you have your one positioned here, how you want it, right? Like maybe it's like this, maybe, or it's like has a little personality to it. It's like rotated, or it's got a little something going on. So this one's here, right? And then you basically just turn this one off, hide this in the scene. Then when it hits the trigger volume, destroy the physics objects, turn on this one. Good question though. Alrighty, so that covers constraints. That's just a constraint. Now what we're going to do is go over setting up a hinge joint on a rigid body. So I'm going to go ahead and let's just duplicate this tall base over here. Put this guy somewhere over here. All right, let's call this beam base. All right, let's give this just a scale of 1 in the X. All right, and now let's go ahead and create another level blocking mesh. Let's create a cube. All right, and let's give this one a. Want this one to have a scale of 7, 0.5, 1.5. This is a real long board. Oh. Get it centered in there. right, so let's give our, we're going to give our object here down here at the bottom a rigid body. So this is the base where our hinge joint is going to be connected to. All right. So I'm going to really crank up this mass, make it really heavy so the player can't tip it over or knock it over or pick it up with the grav null at all. All right, so our actual beam base, or our actual beam, let's call this hinge beam.
Which will say down the
Yeah, I just noticed that. I just dragged the object. I just dragged the object from one scene into the other. Let's go ahead and save it. All right, so with your beam set up, make sure you have your pivot over the spot where it's connected to the other object. And now what we want to do is add a hinge joint to this object. So you need to have a rigid body first, because the hinge joint basically builds off of the rigid body itself. Okay, so in here you'll see a lot more stuff going on, right, than just this rigid body, some things we haven't seen before. So the anchor and the axis, these are really important to have a good understanding of what these are. So the anchor is the position of the axis in which the body will swing, right? And this position is always going to be defined in local space. So it's always going to be in reference to this object. So 0, 0, 0 is right, is right where this pivot is right now. So the anchor is the position, right? And the axis is which axis is this going to rotate around. So right now, when it's set to the axis is 1, who knows how this object is going to rotate if I hit play now? Down this line, right? So always use this gizmo as a little helper, right? Whatever arrow, whichever direction this is pointing, it's going to rotate around that object. So let's go ahead and hit play and see what happens. All right, so it's swinging around that position. All right, and so 0, 1, 0, if you'll notice, that is, if we start here, right, this is 0, 0, 0. Now 1 in the Y is right here. You'll also notice it's a little difficult to see. Let's move this guy out of the way for now. You'll notice in here that this little arrow right there, that little arrow, that is your actual anchor. That is the position of your anchor. So if you take your, if you select in the inspector and you hover over an attribute where you get the 2 little arrows next to your mouse like this, and you click and hold and you drag, you'll see that anchor move. So that is where it's actually rotating, where it's physically rotating from. I want it to rotate from the middle, so let's put it at 0.5. So it's a little tough to see, but that anchor there will definitely clear up some stuff. Also, let's test this out. I think it will also, yep, super helpful. It will point in the direction that it is pivoting, right? So if rotating at a weird angle like that, I recommend not having setups like that. So if I change it to rotate in the y-axis, now that anchor will show me the direction it's pointing. Did I see a hand somewhere over here? No? Okay. All right, so now let's just test it out in the y and see what happens. Just because. So there we something swiveling, horizontally on the y-axis. So for this setup, what? Yeah, and I think now, Cheryl, going back to your question, if we adjust this angular drag, let's put this up really high. Really, really high. So now if I try, I think this will affect, yeah, so this, you see now with the angular drag, as soon as I stop pushing it, it comes to an immediate stop. So the angular drag is more in terms of rotation. All right. Yeah, that should be, if you go to your project and you just type in rigid body sleep right here. And the script is really simple. It's nothing fancy. I think it's just one line on start, sleep on awake. Here. Yeah, you'll have them be on sleep at first, and then, yeah, so basically this is it right here. Get component, rigid body. So all it's doing is getting the rigid body component and setting it to sleep. That's all the script is doing. But here you'll see, requires the type rigid body. I don't think there's a tooltip for this script necessarily, but that was more for the grav null, where it's a lot of attributes. The script doesn't really have any customization because there's just this one line here. You got a question, James?
Is there a way to stay with the object that is moving? So your player moves around, and as when the hinge joint was swinging around, I tried jumping on it, and it just kind of moves out behind you. Is there a way to get your player to follow it? So when you're standing on a platform and moving it?
Yeah. So the question is, how do you get the player to follow around another game object? So basically, you'd have a trigger volume or a volume on your object, and this is one of the experiments in level design. Basically, you have a moving platform, right? You want the player to stay and basically ride this platform. So on trigger enter, you're going to parent that object or make the character a child to that object. And when they leave that volume, unparent it.
Oh, cool. That's easy.
Mind blown.
Thank you.
Yeah, definitely good point. Yeah, really. Yeah, so the question, you don't need a rigid body, and that's a good point. If you look at Unity's documentation, one of their little tips they say, let me see if they still have it here. Right here, right here, hint, you do not need to assign a connected body to your joint for it to work. Not necessary. But what you can do, so if we want to do a little testing, let's make this, so I set our mask really high. Let's make it really low, like 5. And make sure this is really low still while we're testing. So now if I make my base here the connected body. So let's go ahead. So here's the connected body. I can just drag my base into here. You notice it's going to find a configured anchor. That's this auto configure connected anchor. It's going to like auto configure it for you. That's usually fine by default. Won't really break anything. So now if I play, hang on, let me set my tag. So now you'll see that these objects are connected. I can pick up this one, and the other one is, oh boy, I think my beam is a little bit too long. That's why it's behaving a little weird. But this is where you can basically, with the connected body, you can have them as a series and basically create a chain or a rope or some type of pendulum swinging thing. So you don't need it to perform, but having it is basically connecting one rigid body to another at these certain points. So I like to do it, and even a setup like this where it's like not needed, that's why I like to go in and make this mask like 200, freeze these positions and rotations, and then make it a connected body. So just to just have a good understanding of, okay, this object is connected here, and now, whatever, if I move this object or animate this, the other one's going to go with it. Yeah, definitely. Okay, so how do you change the pivot to the corner? So the anchor is the position where it's connected, and the axis is which axis it is rotating on. So that little arrow there will give you an indication. So here I still have it set to the y-axis. How I really want this to behave is not 9. I want this to be on the z-axis, right? And then keep in mind, David, this is all local space. So you'll see 0.50. That is half the distance in the Y, so right smack dab in the middle. If I change this to 1, it goes all the way up to the corner, right? So this is all local space. So now this should be a little bit more resemblant of what I want. Let me check my tags. I forget all the time. Tag this is fizz, now I can interact with this. Alright, so now I have this hinge and it's working properly. But why is it doing this craziness where I can just fling it anywhere?
Because why would it let me do that?
Well, we need to limit exactly how much it's moving. And go figure, they give us a thing called limits down here. So this is how you can control the range for how far your object is going to rotate. So for this one, we don't want it to be, moving all over the screen. We only want it to be a certain range. So we want to, adjust these values to find something that we like. Let's see. I've already done a little testing for this exact setup. I liked, just setting a minimum. It's always good if you're going to set a max, definitely set a minimum, even if you're not necessarily needing it. So I put -90 for the minimum. Obviously, that would mean our board is straight into the ground. Never going to happen, but it's just a good idea to set a min value if you're going to have a max. So for the max, I'm going to do a value of 15. So you can only move it 15 degrees. Again, this is local space. So we're at 0 here, 15 degrees, up from here, and then 90 degrees would be down. So I'm going to set that. And now once you set your limits, also make sure that you check this use limits. Really important. Really important that you have that box checked. All right, and that should be good to go. Now if I rotate my object, it can only go so high. Now you can definitely play with that, maybe make it rotate a little bit more, a little bit less, but now that it's functioning is only going to move a certain amount. Yeah?
So on the brake force and brake torque,
Yeah?
when I try to get my master bezel at the end, if they rotate the platform the wrong way, can I use the brake force and brake torque to cause them to fall off the main object?
Well, first before you ask, you have to understand what brake force and brake torque is doing. And this is, again, why I literally just clicked on this little help info to pop up this manual. So this will tell you exactly what each one of these is doing, especially if I'm not going to really cover, I'm going to try and cover springs in the next 30 minutes before we go. But like some of this other stuff, like the motor and the target velocity, things like that, if you just come in and look at these, it might give you a little bit of indication. So these brake force is basically the force that needs to be applied before the joint is going to actually physically break. So I don't think that's what you're looking for. So that would be basically where how much force needs to be applied, and that's why by default it's set to infinity. Basically, this joint is never going to break. There's no amount of force that can be applied that's going to cause it to break. But for your scenario, I think you may want to have. What did you say you wanted to kill the player, or
No, it just breaks the platforms off and then it resets the plane.
breaks as in like what? Like they animate? Could be an animation.
You know,
Yeah.
catwalks and stuff.
Yeah.
If they move them the wrong direction, they'll break. Like completely off the structure.
Okay.
And then they'll have to use like
Just completely restart the level.
well, not the whole level, just
Okay.
because they all rotate interconnected. Right?
Yeah. So we can take a look at your design and how we can apply this to your design in lab. But you may want to think about not making it to the point where it's this finite, to where if I screw up, now this entire environment is different. And now you need to restart the level or reload a checkpoint. So you may want to think in how, like what that cause and effect is, to where you're not punishing the player too much. But we can talk about that more in as you move forward through level design and project and portfolio 3. You have a question, John?
The break force, you could say, set up like, I don't know, like a chain and like a hinge object in between the chain and the object it's holding. And if you threw something at it and hit it, you could set it to break it. Like,
There you go.
the break force is like 1 or something.
Yeah, or whatever basically whatever that value is on the grav null, right? So if you're throwing something with the grav null of a force of 30, you set your break force to be like 20 or 25, something like that, and test it out, make sure it's consistent, and that would definitely be a way to adjust that. So definitely, this is the type of stuff where we don't have the capacity to have an entire another assignment dedicated to all this, where I could test you on all of this stuff, where you submit an EXE. But really, this is the type of stuff you should be doing like this weekend before you get into the level design, before you really have your concrete design. Now that you have this understanding of these other systems and other ways to build these little setups, go through your levels and add things like this in there. And now that you have, that, you understand brake force or you understand hinge joints, maybe there's a way to incorporate it or improve your level in some way.
Now, I didn't make a basic door for the entry layer or anything like that, but do you use this hinge joint thing for doors?
Yes, that's another good question. You guys are filled with good questions today. Yeah, so basically you can set up a door to be on a hinge and then basically constrain it to only move in the y-axis and then set your limits, and that'll work for a doorway.
I thought it would be a little tedious to always have to interact with the door.
Exactly, yeah, you want to have some variety, definitely. So yeah, in the assignment, I just had put another block underneath it, and I had constrained the object to only move. So that was, a little bit more depth to the setup, right? So if we just want to take this guy, duplicate it, change this. And this is a weird little hiccup too, to where, Cheryl, you had mentioned about little glitches and bugs. I think it's still in here. Oh no, it's not happening. Sometimes when I have a constrained an object, I think if I freeze the rotation. No, it's not happening. So there used to be, maybe they fixed it with 5.3. There used to be an issue when you constrain something to the Y and have a hinge on top of it, would like bounce like this over and over. It seems to not be doing it, but so I just added that little extra block in there again to have multiple steps to your setup, right? So if I just have that block in there, slide out of the way, walk up here, grab your collectible, you're good to go. That's definitely a nice little interaction rather than having just, move debris out of the way, jump on a box. At least now you have a little bit more variety, a little bit more tools in your arsenal. So that's about it for the third experiment. You'll notice in the ending, and again, this is all done in the danger zone. So if you want to go in there and actually set up a setup like this, you can. Maybe just create like a little cylinder off your platform, or it could even just be a cube. So if you want to just create your little platform over here, and you can try this test experiment on your own. Because it's a lot of what we just went over. It's just pretty much applying a hinge joint to a different setup. So this could be maybe you have a pillar or something in your level you knock over, or a player chops down a tree, knock it over. Some type of setup where you're tipping something over to create a bridge. Right? Another use for a hinge to add traversal and interaction. All right, so that's about that for that. So let's go ahead and save. And let's go back to Perforce. Reconcile one more time. Submit my scene. All right, so we have a little bit of time left, so I want to show you guys a test that I've been working on to try and showcase what you can do with the hinges and spring joints to do your best to simulate some type of rope, because it's not going to be exactly what you want. I can tell you that. And that's just because like some engines will have like actual rope physics where you can like have it all moving all around. With the hinges, they really are designed to swing on one axis, right? So if you have a chandelier that you want to like throw and swing through a wall and it breaks, right? You can't just like take it and move it around anywhere. It's designed to just rotate on one axis. So you're a little limited with that, but let me show you a setup. I've see which one this is. Let's see what I have here. Right. So this is a setup that I've been working on. So basically this is a spring joint. And what I did was have the object on the end is a rigid body that I can fling around. So these are basically a series of spring joints with the rigid body at the end and then that connected body in the middle. So that's a little bit of a hack if you're trying to use it as a cable. And obviously these were just tests. These little test cylinders. If you wanted to make this more realistic, you would need more cylinders, more joints. Make them a bit smaller. So what I did there, just added a spring joint. Each one of my objects, right, is see, here's my base, right? Here's my cube, and this just has a rigid body attached to it, and this is frozen in every axis. And now it has a spring joint attached to it because this object next to it, this guy, this is chain. Let me rename these so it's a lot easier. Chain 1, chain 2. Chain 3. So what's important to keep in mind is that these aren't like parents and children. These aren't like the child-parent relationship to each other. Non-kinematic rigid body is no longer supported. Oh, that's because I'm using a cylinder. It doesn't like that. That's why, because it's complaining about this collider. So one thing to keep in mind that these aren't parented underneath each other like this, right? You don't need to set them up to where they're going to move with each other. That's what the spring joint in the connected body is doing. You're plugging them in here. So again, one thing I messed with was basically the spring amount. I set it to 100. It probably could be even more. So if you notice, if I just select these guys, I could do them all at once. So I just set this to like 5. Yeah, does it work? Yeah, sweet. So I set these to 5. This is basically the spring's going to be a lot looser now. So it's like not even, see, it's very spring. It was basically the tension in the spring. The higher the spring, the tighter the coil is. So now this is pretty much not even functioning. So I really had to crank this up high to get it to be something that was, let's try like 1,000. See what this looks like. So a little wonky. There's definitely some weird behaviors going on. But this is a start. This is something that I had experimented with and thought that I had made good progress on, that I wanted to show everyone a little bit of uses of the spring joint. But obviously these are pretty large, the objects themselves, and I think maybe this collider is causing some issues. So if we go ahead and if I just take this object here and duplicate it, I want to just try and showcase the hinge system, where you're having multiple. So basically, instead of a spring joint, I'm going to go through and create hinge joints instead. Oh, I think I remember. So cube. This guy's connected body over here. This guy, connected body here. This guy. I may have to play with this a little bit while you guys are on break, but this should be the same setup. So the one before it in the chain is the connected body to the one previous, right? So they all should flow from here.
How do you think the item not be able to move again?
These constraints, you're going to freeze the positions.
Like you can't push it, but it's freezing all of them just stays in position.
Yeah, I mean, if the player's not going to interact with it at all, like you don't even need a rigid body on it. You just make it a, yeah, it's just a static object. Let's see what happens. It does. First time. Let's see. Let me just try to get rid of this guy. Maybe that's causing problems. No. Could be issues from rotating it too. So with physics, usually not the best idea to have them in game objects. Alright, I'm going to mess with that further and get back to you guys on that. Because I had a good functioning, swinging pendulum before, but I had saved when I had the spring. So one other thing I want to show you guys before I let you go, and this is going to be a little crash course, but really helpful for just working with assets you find on the repository or assets you find online. So let's go to another project. All right, so I'm going to import one other asset. So in my project, art assets, import package. So I'm going to go to the vehicles and grab this pallet, or the, not pallet jack, the forklift. All right, so there's bringing in the forklift with the FBX, all that good stuff. All right, so where is it? Bam. So there's my forklift. But now I'm in my game, or I'm in my level, but I want to have this forklift animate, right? I want to interact with it like we did with the entry. Walk up to it, press E. The wheels start rotating. It translates across. It gets to a spot, and then this lift actually lifts up, animates to move up. Maybe it goes under some boxes, moves some boxes out of the way, creates an opening, right? Well, you can't really do that with this object because it's right now it's just one object, right? So the only thing you can animate is this moving back and forth. Like that's all you're going to have control over. So what I want to show you is at least the understanding and how to modify or change this mesh, at least a little bit, right? So we've been in Maya a little bit. We've dabbled in it a little bit this month. And understanding UVs as a designer is good. You're not really going to get a job where you're going to be UVing objects all day long. That's not what designers do. I wanted you to at least be able to hold a conversation with an artist, or maybe put some proxy UVs on an object to put a material on it. But this is going to be a little bit more useful long term, in my opinion, in case you make your own assets or you download something from the internet. Being able to adjust it is really important. So I'm just going to, this is the FBX object itself, right? Make sure you're not grabbing the, maybe I grab the prefab. Yeah, so make sure you actually grab the FBX, right? So here's the 3D object. And if I go make this full screen, you see on there forklift.fbx. You can grab it from a file explorer, or you can just drag and drop it right into Maya. You can, I promise. It's probably really large. There it is. So it's really big. So you'll see, again, same thing when I bring this in. I have one object called mesh, right? Not really helpful. But what we can do, and now this mesh is really well modeled. A lot of this comes down to how it was modeled, to how easy or difficult this is going to be. So if you go to face mode, right click on your object, hover over this menu, go to face mode. So I can say I want to separate all these tires out. So each tire is a separate game object, right? Now I'm in face mode. I can just double click on the object. And so what double clicking does when you're in face mode, it's basically going to select all of the faces in that contained object. So when you model something, you don't have to start with a cube and extrude and make everything from one piece. The motto of game art is just shove it in. Like, you don't have to actually physically model the tire with the hubcap separately, right? You just have one object. So I'm just going to select my tires, hold shift, and select all these. All right, so now with my tires selected, I'm going to go ahead and hit mesh separate. So you'll see over here it created this symbol here, this is basically representing an empty group or an empty node in Maya, similar to how Unity creates an empty game object, right? So next to these, you'll see this symbol over here that looks like a little plane. That's representative of this is a mesh. The cameras have a little camera next to them. They do a pretty good job of labeling so you know exactly what each object is. So these are empty objects we're going to get rid of eventually. But now you'll see we have these 5 objects here. Polysurface 1, 2, 3, 4, 5. So real quick, let's just go ahead and name these. Just going to call this tire 1, tire 2, and then we'll call this one forklift body. Okay, so now we have basically we have 5 game objects now, right? And they're all in here. So what we want to do, first thing, let's go ahead and delete from our history. And now, so basically you still have the ability to parent and unparent things in Maya the same way, except you can't just drag and drop. They make it a little bit more, a little bit extra steps. So what you want to do is, so if you go to the edit menu here, you can parent and unparent. So first thing I'm going to do is I'm going to get them out of this empty group node. I don't want this empty thing here. Actually, it's probably not a bad thing to keep, because we can put our, yeah, let's just remove it. We can add that in Unity if we really want it. So I'm going to select all my game objects, right? And now hit, is it Control Shift P? Yeah, Shift P. So Shift P will just unparent, right? Now I get them out of here. I'm just go ahead and delete that group node, that node. We don't need that anymore, right? So now I want to have my tires be children to my body, right? So I'm going to go ahead, select all the tires. So select the children first, and then select the parent, and now hit P. So child first, then the parent. The last object you select, they'll all be parented to that one. So now you'll see a hierarchy like we would see in Unity, right, where we have our regular game object and our sub-objects below it. So that's good to go. So again, let's just go ahead and delete the history. We didn't move it. Our pivot should still be good at the origin there, right? Nothing major changed. So let's go ahead and export this. I recommend exporting it not named the same thing, so you have a backup version.
We haven't got that thing in Unity from the word.
The Maya plugin? No, I haven't really used it too much. So.
You just working on real,
So I have that forklift model, and I saved it to my desktop. If you save it right to your project, it should appear in Unity. But I saved it to my desktop. I'm going to drop it in here. So now you notice when I drop this one in the world, oh, I didn't have everything selected. So definitely make sure you select all the game objects, not just the parent one. Select everything. Export. Desktop. Plug this in. So now you'll notice same hierarchy that I had before in Maya, I now have in Unity, right? So here's my forklift. If I want to have a tire be a separate object, or now I can actually animate these to rotate, right? Or maybe I want to have the tire, I want to have a stack of tires somewhere, right? So I can duplicate this now, position this in the world however I like. So that'll give you a little bit more control in animating objects, making them a little bit more complex to what you've already been exposed to. So that's just a little bit of understanding. If you want to combine things in Maya, same thing. So you have this mesh separate. Here's combine right here. So you can just hit combine. It'll combine into this one game object right here. So separate and combine will get you far. So definitely do a little bit of testing with that as well. Take one of the vehicles from the depot, or take one object and try and break it up into multiple pieces. So maybe our forklift or our pallet jack we worked on, separate the handle off. Make the handle a rigid body. The player has to go find the handle, attach it, and then it moves out of the way. Sound good? Cool. Well, that about does it for us. So feel free to come back at 1 o'clock. And really just going to be working